Model number 2. Now, actually, this is the main product we talked about in the during the sessions, the PUK85R. This one is capable of pumping 84 liters per minute if the pump shaft is rotating at 1000 RPM. Of course, we can increase the flow rate by increasing the RPM value. Made of cast iron, or it can be made of steel, or it can be even made by a certain type of alloys, if I get to use it in different applications. Now let's talk about a refinery. And you know that the temperature in the refinery is going to be quite high. If I'm going to use the aluminium one, I say aluminium because it's laid behind me right now. We're going to use aluminium pump. It's going to enlarge due to the high temperature, and this will actually going to make, well, maybe shaft is going to be enlarged inside the aluminium part, and then we're going to have some cavity in between them, and it's going to lose the efficiency of the pump. Now this one is made of steel. It can take higher pressure as well, okay, or cast iron. Higher pressure, steel can take even higher pressure, and the super alloy can take the high pressure and the temperature and keep the same performance of the pump. This one is of course larger than the previous one. You can see from the size comparison. The height is higher, the weight is higher, and this actually going to affect on the assembly process negatively. Of course, because it's going to be larger, that means that the amount of the heat required to melt the cast iron is going to be higher, of course, than the temperature required to melt and pouring the casting for the aluminium. So we have advantage and disadvantage for the selecting of the metal. The shaft, of course, is going to be made of the steel, and the thrust plate here is made by die casting operation for the aluminium. It does have some details on it where the steel is going to be sitting in these groups. Now let's talk about the manufacture process. It's not going to be much different from the previous one. The main body is going to be done by casting operation. It's going to be a sand casting operation. There's no other method to make this part because it's made of the gray cast iron. They require higher temperature that the die casting, even if we can modify the shape, will be able to take it. After doing the casting, we are going to do the same processing like the face milling, the drilling, the tapping, the drilling and the reaming for the dowel holes. And dowel holes, you can see here, is going to be sitting on these sides. The number of the holes here is going to be 6 instead of the 8 we had on the other side. The same thing will be happening for the face milling and the threading operation, which is going to be done on the milling machine. We need to do some boring and face milling for the details we have inside the pump, and this can be done once again on the milling machine by having the costume cutting tool, which we say is going to have 2 levels, 2 cutting tools, and it's going to do the boring and the face milling in a single go. The main body doesn't have any special shape like the previous one, except that it's going to have this slot cutting here, because this one actually is going to have a seal that prevent the oil from leaking. Just remember that because we pumping at higher pressure in that case. Other details not going to be much different. We are going to have the face milling, the drilling, and the bore and the reaming for the dowel positions. The same thing is going to be here: face milling, the profile cutting for the circle in the middle, and enlarging the diameter of the housing for the seal. We have the housing for the shaft, for the pushes here, also need to be bored and reamed to the correct dimension. The shaft is going to be cut by the turning operation. We hold from the side, start to do multiple cuts until we're going to have the correct dimension. We do the gear cuttings, the supply cutting, and then we send it for the heat treatment, and then we're going to do the final grinding process for the part. We can do the grinding for the gear teeth and grinding for the sides, and we can add sewer finishing, and we can also once again do the surface treatment by add the chromium level, or we can add the nitrogen level to make it stronger. The same thing will be done for the other shaft. Now, one of the good things we have for this shaft here is we're going to put it in this position. You can see that we have the correct level for the gears, the same level. And this will be an advantage in the case of the assembly process. Before we're going to do the dimensioning, and let's have a look about the thrust plate. Thrust plate is made by the die casting operation, so we can have the mold keep injected with the molten aluminum and get the spot continuously. The thrust plate, actually is going to be on this side, will be sitting between the shaft and this surface. Okay, so thus when the actually is going to, as you can see here, is going to have a protection layer, okay, which is going to be the thrust plate. Thrust plate is going to keep the pressure high, and also it's going to be sacrificed before the shaft or the main body is going to be sacrificed. We have another one should be sitting down here. So if I'm going to make an overhaul for the pump, I know that the main part need to be changed. It's going to be the seals and the thrust plate. Okay, now we are going to go to the dimensioning of the pump.